Imagine that people wear augmented reality glasses to go through everyday life activities in the near future. They move in between spaces for different tasks, benefiting from the digital augmentation by AR. How should the UI respond to the contextual changes as people move around? Current solutions either require users' effort to move the UI manually or simply keep the UI on the heads-up display, occupying the field of view constantly. Neither is ideal. To find better solutions to transit UI in different spaces, we first ran a design workshop with UX experts. Participants did a bodystorming session, carrying out a sequence of tasks in different rooms of their own homes. They also used a HoloLens 2 prototype to find relevant AR content for the tasks. We made the prototype to represent the state-of-the-art UI transition mechanisms on commercial AR systems. Users have to manually move or re-instantiate the UI widgets when they are in a different space. We included 8 widgets in the prototype. During the workshop, participants used the prototype to help them access AR widgets when they need to complete the tasks in different rooms. Through the Bodystorming workshop, we learned about the challenges users encounter when they need to access digital AR content on the go. We also generated design ideas and improvements to address the challenges from the workshop. We then designed, implemented, and evaluated 3 interfaces with different levels of automation and user control. Due to COVID and unstable wide area tracking with current AR devices, we created the tasks and interfaces in VR with the goal of simulating spatial AR interactions as much as we could. The first interface we call it Wrist Pack, which aims to reduce the user effort by packing the active UI widgets onto the user's wrist when they leave the room. The user could easily pull the relevant widget from the wrist pack to view them at the new location. Second and third conditions are called semi-auto and fully auto, both of which leverage the system's capability to detect the change of space and task, and predict when and where the UI is needed. Of course, because in VR the system has full knowledge of the space and tasks, it was easy to simulate the predictions. In a semi-auto condition, a list of the system's recommended widgets are presented to the user for the new task, and the user makes the final choice of when and which one to place. In the fully automated condition, the system's top recommended widget is directly attached to the new task space. More importantly, we simulated the error that may occur when the system tries to predict what UI widget is needed at a new location. We are very interested in learning how the error impacts the user's experiences. To compare and understand the pros and cons of these interfaces, we ran a user study in VR. To mimic the spatial tasks for AR use cases, users need to go through tasks located in different rooms, including a kitchen, an office, and a living room. Participants could touch a button on the virtual door to move between the 3 rooms. They can also move by walking physically or by using a controller to raycast and teleport. In the task, every user goes through 12 trials per UI condition. In a single trial, participants were asked to go to a different room, interact with an object, and access a widget to answer a multiple-choice question that popped up. We evaluated and compared these interfaces for their efficiency, agency, workload, user preference, etc. We found that semi-auto condition resulted in the best performance, higher user preference, and agency as compared to the rest of the conditions. We learned valuable lessons about the relationship between automation, controllability, and agency. We also learned why the system's prediction error led to frustration and how to mitigate it when it happened. Based on the results, we provide insights to further explore predictive and automated UI mechanisms for everyday AR interactions. Thank you for watching.